Hey champions, welcome to the next video in the series. We are learning about regression, and regression is one of the key techniques. And we've covered three steps in many ways. So, starting from the business in terms of framing the big picture and the objectives, we've been looking at a housing pricing as a example. It's about predicting the price using regression as a technique, right? So we've been looking at that. So we've looked at how do we frame the problem, how do we look at it in the business context. Then we've talked about data acquisition and things like that. In this case, that has been minimum, but in reality, for you, that could also be a bigger activity. And we've talked about things that you may have to do from a data engineering standpoint and data acquisition standpoint, right? Then we looked at exploratory data analysis. That's a key topic where we looked at the entire thing around how do I look at the various attributes that have been provided, the descriptive statistics, the visuals, the relationships, and so on and so forth. Okay. Now, with that, you have a good understanding of what it is. And just to refresh your memory, we've been talking about using KNIME as a no code tool. It allows you to learn a lot of things very fast without having to do a lot of coding, right? So that's why I love the platform in that sense. And if you choose to do coding, you can also bring that in with Python code and so on and so forth. Okay. All right. So we've looked at the initial steps as well as exploratory data analysis, like I said, and then now we are getting into data preparation, right? So if you look at data preparation, there are couple of key steps that are there. I'll just do a quick view here and then we'll jump right into KNIME so that you can understand what are we trying to do here. Okay. So from a data preparation standpoint, there are a couple of things that we need to do. So the machine learning models generally like to have numeric data in good set so that we can build a model and we can go with it, right? So we have seen a lot of outliers, some missing values, and so on and so forth. So therefore, I have to do some preparatory in terms of the data so that I can make a meaningful analysis and leverage some of these models, right? So one of the first thing is we will treat the numerical attributes in some manner, and then we'll also have to treat the categorical variables, which are your proximity to ocean and some of those parameters which have like a bunch of categories, right? So your red, blue, green type of categorization, or gold, silver, platinum if you're dealing with loyalty, any of those examples. So categorical variables, we may have to treat it slightly different. We have to do certain things. Okay. So I'm going to walk you through step by step the key things here, and then we will, when we do KNIME, we will quickly go through the details, right? So one of the first things I have to do is treat missing values. Now missing values, there are okay, if you look at the big picture, so obviously we have to look at missing values. Then we have to look at scaling the features, because some of the attributes may be in units that are different from the other attributes, like amount tends to be different than quantity and so on. So if you put them in the same model, you may not be doing justice because they are of different units, right? So scaling is where we are making sure all the values map to a scale. It could be 0 to 100, 0 to 1. 0 to 1 is typically what people look at, right? And then we can rescale them later, or when the model comes back, we can reinterpret. So scaling is something that's important. Categorical as well, we need to look at treating the missing values as well as encoding the data. So encoding means I can't input like platinum, gold, and silver to a model because that's textual category. Rather, what I would do is I'll create there are multiple techniques to do encoding. So one of the approaches we are going to look at is one-hot encoding, where we will take an attribute and then create columns to indicate that wherever it's gold, silver, platinum, those particular values are highlighted, and I get a 1 or a 0 to indicate that this particular data row is belonging to category X and Y and so on and so forth, right? It will become clear to you when we look at the KNIME part of it through example, but encoding is a typical part. There are multiple ways to encode, and that's one part, right? So once I've handled missing values, I've taken care of scaling, I've taken care of encoding the data, and so on and so forth, right? Then I have to also look at skewness of the data. So if the data is too skewed, then again it's a problem. So we would like to have a normal distribution in some case. So we also handle some bit of that from making the data normal as well in that sense, right? Now once I've done all of this data preparation and so to speak, then I can go and do train test split. Now you need to split your data into training and testing, because you need some manner to some approach and some way to say, hey, the model has learned the right things, or the model is giving me the right equation, and therefore this is how I can validate. So we use the training data set to train the regression models or any kind of other models. We use the test data set, or sometimes people also use validation as an interim step. But we'll keep it simple by saying, hey, train and test are the two categories. So I use the test data set. Once the model is built, I use the test data set to go and check whether the model is able to predict the values that are available in the test data set. So the test data set is going to give me a particular actual value, and then the model will be able to predict, and I can compare the two to say, hey, what's the level of error between the two, or the degree of error, right? So in this case we are predicting price, so I can look at comparing predicted price with the actual price that's available in the test data set, because mind you, test data set is not something that the model has seen, or they're not learned on that, right? So that data set, we have kept it aside, we have not trained the model on that, right? So that's what it means. It's just purely used to validate the model, right? So I take maybe 20%, 30% and keep that aside, right? So some folks use validation as a separate smaller set, and especially when I'm building many models, and then finally once I've finalized a set of models, I use the test data set as well, right? So when you do cross validation and so on, you may want to have validation split as well as this. But for this exercise, you can keep it simple, say train and test, and learn from there, right? So with all of this, finally you will have the trained data set available, and you can go and start looking at the next step, which will be building the model, right? So that's your high level step in terms of being able to prepare the data. Now I'm going to switch to 9. So 9, we've already talked about the various steps. Just to quickly refresh your memory, so here's the housing data set. It's got lat long, it has got the median age, median total number of rooms, total bedrooms, and so on and so forth. And we saw that in the total bedrooms there are 207 values that are missing. In all other cases they are pretty much okay, and so on and so forth, right? And then you can see the mean and the modes and all of these things. So all of the good stuff that's there in the core data. And then we also saw visualization. When I looked at exploratory data analysis, we saw various ways to understand the data through histogram, through visuals, pie chart, as well as scatter plots that show us what is the visual, right? So I can look at any of these and literally look at this. So I'm just going to open one and then show you just to see what it is. So this is a quick scatter plot of the price values, housing price values, and against latitude and longitude. So I'm trying to just plot the values and see how it is. And if you can see that it's somewhat resembles the California map, so to speak. And then you can see a lot of density of houses are more near the bigger cities like Los Angeles or San Diego or San Francisco, and so on and so forth, right? Which is expected, because that's where a lot of high population is there, and so on and so forth. And these districts are more densely populated than maybe the others, right? Okay, so we have gone through all of this in terms of exploratory data analysis. Now let's go back to our next step. So next step is, in this video we're going to look at data preparation like we've been seeing here. So so when you look at data preparation, there are a couple of steps that we have gone through. So I've created a 9 workflow which mirrors these steps, and therefore you can easily follow this and go from there, right? Now these sub workflows or the groupings are easy to create and easy to follow as well, okay? All right. So one of the first steps we are going to do is, so we saw what are the treatments, data treatments that we are going to do, right? You could do additional ones, but the key ones that I've talked about that will help with the model in terms of preparation is what I've shown here. Okay. So first thing is we have something like an income category. Now income category is as you can see, income category. If you look at the values here, right? So for example, my values are in 8.3, 8.4, 3.8, and so on and so forth. Now that means they're probably in tens of thousands of income. So somebody is drawing 80,000, somebody is probably drawing 100,000, and so on and so forth, right? So that is like the average income in that district. That's what it's indicating. But when I'm building a predictive model for predicting the price of house, I'm not interested in the exact income that somebody is drawing. I'm more interested in certain categories. Hey, does he belong to the higher upper middle class, or does he belong to does the person he or she belongs to the middle class or whatnot, right? Or they are low wage earners, right? So depending on the range of, or also the category of the income, right, we can detect whether a particular district is going to be in the higher price mode or not, and then what could be the price, right? So I don't need to know the exact income per se, because that's going to be difficult sometimes even for you to get the data in a real sense when you're actually using it. But you could get a range and you can play with it from a scenario standpoint. So one of the techniques we use is called binning. So I take a continuous variable which is spread between, let's say, 0 and whatever. So in this case we are talking about our values are spread between 0 and let me just open this median income. So median income, if you look at it, it's got the maximum is 15 and minimum is 0.5. That means this is probably dated data, like this is old, right? So probably at that time people were earning upwards of 150k or something like that, right? So so on and so forth. Okay. All right. So how do I do my binning? And then you can look at the pie chart here, to which where the categorization and visualizations are there. So this gives me a quick split of how the rich and the middle class and all these players are there. Now these are categories I've created, and I'll show you in a minute how I created the categories. But these categories are going to help me say, hey, anybody falling in this range of income, or I'm going to call them super rich. Anybody in this range, I'm going to call them middle class, and then I can see what the distribution comes out to be. Okay. All right. So how do I create binning? So binning is it's a widget again. So once you populate the widget, you will get you'll be able to choose the column, and once I choose the column, I can create these. So I can go and add another bin, and so on and so forth, and so on and so forth, right? Now, for example, sorry, I'm just going to cancel it so that it's easy for you. So you can add a new bin, right? So as you add a bin, let's say for example, you can give it any name, and you can give it a range of value. So you will have extreme values which are at the lower end of the spectrum and the higher end of the spectrum. So those you may want to take care of in some manner, and then the different bins within that, right, in the intermediate category. So the one extreme is there is no wage data, or somebody doesn't earn any wage or something like that. It's probably below a certain limit, and therefore it could be values leading up to zero wage or something like that, right? That could be one of my categories. But the big other bins could be like, okay, if you're earning between 0 and 15k or something, you're working. If you're earning from 15,000 to 30,000, you're middle class, right? Depending on the data, you could do this. Now I've chosen to just categorize them into 5 or 6 bins now. So including, if I include no wage, it's sort of 6 bins, right? But you may have a couple more, and so on and so forth. It's more of your knowledge of the business that's going to play there, right? So this is how. So you can just create these bins. You can specify the minimum, maximum value. I can change any of these, and then if I change, it will reflect, and then I can append the column name and say, hey, this is the column name, income category rich, right? Now what happens is, so this income category, if you look at it, so when we execute it, you will see that the medium income bin. If you see at the bottom, that's a category that has been created. It's showing 5 unique values, and that's what we're looking at. So these are categorical values that is created, and then the same thing I showed you in terms of a visual chart as to what is the distribution of the income. So now, given our categorization, we see some equal distribution pretty much, but then maybe certain categories it's less. So in the working category it's probably less, but most of the people are earning, they're either in the middle class or in the upper middle class type of range, right, which we know generally to be true, right? And then there are super rich, which are like 10-11% of the game. Okay, all right, so that's one category, one step. So I can take any continuous variable and then divide it into bins, so that I can use it in my real application, whether it's for marketing or determining the price and so on. Okay, all right, let's go to the next step. So now we said we want to make sure the missing values are handled. There are a lot of strategies to handle missing values. By and large, you could say, hey, if the number of rows are less where the data is missing, I could ignore them, or I could go and say, hey, just use the mean value, or I could use a constant value and so on, right? So NIME also allows you to do all of that. Now I can go and take all my numeric and apply a strategy. So this is like a strategic approach you had. Let's say you have 5 or 6 numeric columns, many values are missing. You could say, hey, consistently, I'm just going to use mean and replace all the missing values, or rows which have the missing values. Or I could do median, minimum, or a maximum, or a average, and so on and so forth, right? So in this case we have, or you could do a fixed value. Say I could say, hey, look, this is income category or something like that, and I want to make sure every middle class is something that I want to put, right? I could put that category, so things like that. So or any numeric value, income to be 10,000, 10k, or 30k, or something like that, right? All right, so that is, I could have a fixed value, I could have a frequent, so if it's string, let's say naming of proximity to ocean is a string, right, as a categorical value. So you could look at what is the most frequent value. If most of the people are staying closer to the ocean, then there's a high probability that the missing rows can also be in that category, right? So those kind of things you could look at. Okay, so this missing value treatment will allow you to do that when I execute it. So I've already executed this because it's green, so that we could save time on those parts. So now if you see, right, when you look at the statistics, I don't see any missing value in the total bedrooms that was there. So before we had some missing value about 210 or something like that, right? So those are gone. Okay, all right, so missing value treatment is the second step. Now third step is, we said there are various attributes with different units. Now for example, age of the house is not is in a different it's in number of years or so, versus number of rooms, or the total rooms is in single digit numbers, right? Now these are not the same. They won't, if some let's say if you see a value of 5 for age versus room, right, they may be different, because one is in years and one is in this, or I could have the age could be in months, right? So things like that. So these units are different. So I'm going to try and scale them to a standard value like we've been discussing. So how do I do that? If I look at the settings, you will see that I can give a range value. So scaling is a widget, normalizer. If I use normalizer, I could say, hey, use min max scaling or z scaling or any of these. So these are standard techniques which can be used from a scaling standpoint. So we assume, let's say, normal behavior, and we could scale in a certain manner relative to the normal mean median. We could do so. That's one type of approach, which is z scoring, which is basically an equation based approach, or simple approach to say, hey, take minimum and maximum values between 0 and 1, 0 to 100 or whatnot, and then scale all the values to this. So wherever it's 8, it's going to do a relative mapping of 8. Wherever its age is 10, it's going to do a relative mapping to a scale of 0 to 1, right? It will look at the data min and max within the data set, and then it will apply this from a ratio standpoint, and then you will get these values. Okay, so simple approach, but you may want to do that as well. So from a scaling standpoint, this is an important step. All right, so once I've done the scaling, then one of the other problems we have seen is the data is queued in many cases, right? So give me 1 second. Okay, here. Okay. So we've seen that some of these values are skewed. Like of course we are seeing price here. I could apply others like so we have seen in the exploratory data analysis that values are skewed. But it's good to have normal values because certain models assume normal behavior of data set and relative to the normal. So when I look at standard deviation and other parameters being applied, it's easier when we talk about a normal data set, and that's when we can do the proper interpretation relative to a normal distribution, right? So I'm converting some of these which are skewed to more of a normal manner, and I can use a mathematical formula. That is one of the approaches. So here, if I look at the data set, I'm saying just take a log normal, and then see how this value applies, right? And I can give it a name, which is so I can store the original number of rooms as well as the log total number of rooms, and you'll get some value, and then you can see the distribution thereafter. Okay, so I think yeah. So the histogram, now this is not perfectly normal, but it's not skewed towards one end, right? It's there's some distribution to the left and right, and then I can see most of the rooms are falling in some manner, and so on and so forth. Okay, so you could do this. You can do analyze some of these. So likewise, I've done for total number of bedrooms, population, housing age, log households. These were all skewed data set, and now I have these attributes that are created in that sense, right? Now I tend to retain the original attribute so that I can compare and I can go back to that if needed at any particular step, and in the final set we can do the treatment as we go along. Okay, all right. So I've done the missing value, I've done the categorization of continuous to set of categories, scaling of the data, then handling skewed data set from a log normalization. So these are core 5 or 6 things we have done. Now let's talk about categorical data set itself. So now one of the key categorical data set we have had is around, let me just see what happened here. So one of the key thing was around ocean proximity. Now ocean proximity, we have seen that it's got, what has happened here? Give me 1 second. Yeah, so ocean proximity, if you look at it, it's got to reset the value. Yeah. Okay. So if you look at ocean proximity, so you will see that that's got about 5 values there, right? So it's basically near ocean and so on and so forth. So now I'm trying to, so if I go to the previous step, it's be more visible there, right? So we had about 5 categories there, and we've looked at if you look at this data set here, ocean proximity, it's got 5 unique values and so on and so forth. Okay, so I want to make sure the strings are converted to something meaningful from a numeric standpoint, and therefore one of the approaches is it's called encoding in that normal sense. So one hot encoding is one of the approaches. So I have a widget which will take my single column and then convert it into multiple columns. So essentially for each of these values we are saying, hey, create a variable and then attach that variable, right? So what have I done here? So if you look at it here, when I execute one to many, all it is doing is and I specified the value as ocean proximity like I showed you earlier. So this is the value for which I want to do one to many, and one to many, what has happened is it's created different columns. So if you're near the bay, it's marked these rows as 1 to whatnot, and then there could be others. Now our data seems to be sorted, right? Let me just go down here. So now these rows are probably one house next to the ocean or something like that. But they are not next to the bay, right? So these values are marked as 1 against the category of near the ocean or something like that, right? And inland is another category. So set of rows which had that as a category will be marked with that. The other values are marked as zeros, right? So essentially you now have numeric values that are clearly indicating, and these attributes will be part of our equation and we can interpret, right? So this will tell me whether being closer to ocean is an indication of the price or not, right? Or being inland, is that a determinant of the price or not, right? So those kind of strength of these attributes can be part of our equation. Okay. Now similarly, we can look at income category. Like we did a categorization of the income, and we converted that into set of strings, as you saw, middle class and upper middle class and so on. So therefore I need to also do a one-hot encoding of those, right? So those are also taken care. So if you look at here, we did medium income binned, which was the value we had stored, and now we have these categorization. Okay. Alright, so now I have done all the categorization and one-hot encoding and all that. Now one thing I tend to do is I tend to save after all the exploratory data analysis, data preparation, and then I'm fairly satisfied with the data, and I'm now getting ready to build the model, right? I go and save the data so that you don't have to repeat some of these steps again and so on. You could start with this clean data set or a prepared data set, and you can work with it. Or if you have a team member that's building additional models and so on, you guys can split and use these files and so on. So it's a good practice. If the data is too huge, then it's a different story. But by and large, if you have manageable sizes and you're able to storage is cheap these days, right? But in any case, it's good to have this intermediate, and then you can also use that to analyze the data set, and when you're discussing with business, you can use it, right? So that's one step I look at, right? Now what I was saying is, so I've written this to a file, a CSV. Now instead of running, so if I were to rerun this model again, I don't have to rerun all of these steps around exploratory data and preparation, because I've already done that multiple times. So I could just remove this link, and then I could attach this file as an input versus to my model building and so on and so forth. Okay, so you could do that. And then second thing is, as part of the data preparation, as we saw, we had quite a number of columns. So this is something that the same data set I had saved it earlier. So I'm just going to open this. So this is the file we had, and as you can see, right, we had converted categorical to numeric and so on and so forth. Now I have number of columns and so on, and there are some which are redundant, because that means they are indicating the same type of meaning in terms of this, like median income and the income category. They indicate, both indicate income part of it, right? So I don't need both. So that is the other step where you are using column filters. You could filter out certain columns and say, hey, when I'm feeding to my model, I could be I would like to limit. Now I have not connected it to any node, but I'm just showing you the concept that I could do column filtering and say, hey, look, I'm not interested in certain things. I'm only interested in feeding certain values, right? Maybe these categoricals and stuff like that, and then I can ignore row number and medium house and all of these, right? So whatever is and if I want to play around with it, and model building is again going to be an iterative process. So as you're iterating through this, you may want to play around with and say, hey, what about if two attributes are closely correlating very well with each other, then I may not want to include them, and so on and so forth. So you did the correlation analysis earlier, right? So you could remove those. So column filtering will help us say, hey, before feeding the model, just include these subset of values, and then start with the model building. Okay. All right. So there you have it. You saw the entire flow in terms of now my data is prepared, as you can see here. So we've gone through the data preparation, we've gone through missing value, and then now I keep the train test split within the model preparation step. You can group it under prepare, or you can group it there. It doesn't matter in terms of thing, but it's always good to keep the partitioning either at the fag end of the entire data preparation cycle or at the beginning of the model cycle, right? Both approaches are fine. It's okay. All right, so that's the train test split. So now we will come to this part in terms of model building in this. Okay. Now let's go to this, let's go deep dive. So now I have prepared my data. The data is there and I'm looking at certain values and so on and so forth. Now if for some reason you not handle missing values or whatnot, right, because we were using the file or so on and so forth, you could complete that part. And then my partition will, partitioning, like I said, is one of the first steps we want to do from a model building standpoint. Now model building as such is a not a complicated step. It's all this data preparation and data engineering that we had to do, typically takes time, right? So okay, so now partitioning, I've given this options where I've said split this into based on relative percentage or number of rows, whatever it is. So you may want to say, hey, give me 5,000 out of the 8,000 for training, right, or testing. You could do that, right? And then you could do sampling. Now train test split is can be little tricky. Now you could draw random, or you could do stratified sampling, but there are various sampling techniques. We'll keep it simple in these videos, so that's why I'm not complicating it, because otherwise it will become a little complicated. Now essentially sampling means if my input data has a certain type of distribution, let's say there's 60% of the data has male and male population, and 40% of the data had female population. Not relevant here in this case, but let's say for example, or in this case we have these near the ocean and inland type of a categorization, right? So now let's say 80% of the data is near the ocean, right? And hypothetically 20% was inland. So when I'm selecting the train test split, I want to keep that ratio. I want to make sure that split of 80-20 is there in, and therefore sampling will allow us to do that, right? I could do simple sampling, or at stratified sampling is what I explained. Based on certain values and attributes, you could do the so that kind of stratification is retained in the target train data as well as test data. Okay, so this is simple. You just specify the percentage split, and you will see two sets of partition. The first partition, as you can see, it's about 14,000 rows, and then the second partition, as you can see in the data set in the summary, about 6,000 rows, right? So roughly whatever 30% split and so on and so forth that we talked about. Okay, now the training data is what you're going to feed to the model, and then test data is what you're going to do the feed to the predictor. Okay, now let's go to model building. So model building is the core exercise. Now when you look at regression, there are multiple widgets available within 9. Now if we are doing Python code and so on and so forth, there again it's quite easy. Scikit-learn has set of linear regression and various techniques that are available that you can use, right? So since we are doing no code approach to keep the learning simple, we can quickly go and search for various regression techniques. So if I type regression as such, you will see various types of regressions are available. Now we have talked about linear regression as an approach. It could be non-linear, it could be polynomial. Polynomial means there are multiple relationships of higher order, x square and y x cube and all that, right? So we're not going to go into that, but you will see that there are multiple widgets available for us. So I could go and use these, right? So there are two sort of paired widgets that you will see in this case. There's a learner, which is the model, which is the widget that will train a model, and then predictor is the other one that the paired value that you want to predict the regression of the price using the test data set, right? And then we'll compare the predicted versus actual using the numeric score and so on. Okay, so this is the simple approach. So I could just drag and put like any other widget. So now let's look at linear regression. Now in linear regression, all I'm saying is, like if we had not filtered the column, now all of these values are going to come. In the first iteration, I'm just going to probably use all of these and then look at what the equation comes out to be and so on and so forth, right? So you could just include or exclude any of these values. Now one of the key things is you have to specify the target value, which is the housing price or the housing value, right? The median housing price or housing value. That's what we are trying to predict. So the model will try to look at, right? And there are other aspects to say, hey, can I ignore missing values and so on and so forth. So those things you can take care. Okay. All right. So linear regression will allow you to look at it. So now I can execute the the regression equation and I can see certain things that are coming in. So regression is nothing but and we have seen that in the concepts equation, where essentially we are trying to get an equation which is to say, hey, y equal to mx plus c, right, which is in simple terms to say, hey, what is the line that's going to help me with the least distance as when I'm plotting these values, right? So that's what we're talking about. Now here we have bunch of attributes, and each of them are each of them have certain effect on the price, and those effects are indicated by these coefficients, roughly when you see, right? So lat long has some negative effect on the price in some ways, but let's say medium income has a very high positive impact on the price, and so on and so forth. So these are coefficients. So when you say y equal to mx plus c, m is the slope part of it, but these coefficients are the ones that are going to be part of the equation, and that will help you define the equation. Okay. So, and then you will see some standard error values and so on, but to keep it simple, we'll say, hey, look at these are the coefficients that are going to be determining how am I going to use it, right? Now the other part is the confidence in the model. I think we have talked about this part earlier, where R squared tells me what is the degree of variation in price that's explained by the model that I get now. So these coefficients, essentially now what did we get? We got a model which is a mathematical equation, which is to say, hey, minus 0.40 into longitude value, minus 110 into housing median, and so on and so forth, right? It's you get that equation in simple terms. Now that equation is what can be used to predict predict the price for a new data set, right? So if I'm talking about a new district or a district in some other state, maybe assuming it's similar to the behavior of California or something like that. So I'm applying it to a new scenario, a new data set, and when I feed these values, I will get the median price, which is the intended purpose of what we're trying to do from a regression standpoint. We're trying to predict the value of price, medium income, estimate the value of medium income, and the equation can help you with that, right? So R square is one of the measurable values which tells us how much of the variation is explained, variation in the price or the income that I get is explained by this equation. So in this case, let's say for example, to keep it simple, we're talking about, let's say 70%, 67% of the variation is accounted for. There's about 30% or 40, close to 33%, which is not roughly accounted for, right? In that sense, that means there are probably other factors that are maybe affecting the price, and so on and so forth, right? Or there could be other things. Okay. All right. So this is as simple as that. So I have my R square and so on. Now the other way so this is statistically I get to know this. Then when I look at the predictor, so like we have the train and the test bit, I apply the test data set, and then now when I look at the test data set, I want to see the predicted values as well. And typically you will store these predicted values as an attribute, so that you can compare the actual versus the predicted, right? So in this case, I'm storing that as a predicted linear regression value, because you could have other regression models that are estimating, and you can add to it, right? So as you can see, in this I have stored this median value here, and then we can compare that with the other median income, and so on and so forth. Okay, so that's what we are going to do here, right? So this is as simple as that. Now these other steps are just to make it easy for you to understand. These are not necessarily important, but they are optional in that sense. So column sorting is, I've just said, okay, just sort it in a certain value, so I can compare actual versus predicted and easily look at it, right? So you could sort the values in a certain manner. Now when I look at the actual versus predicted, I can see these values which are closer to each other, and visually I can easily see that they're probably matching in many cases, but there are probably many cases where the values are quite off. Let's say for example, this row number 27 is 0.47 versus 0.53, right? So things like that. So the error rate, the error values can be little high, and you can do the error values, and you can also plot that. Okay, so now I have my actual value and then the predicted value. This is where I'm getting the score, and I am trying to run this. So give me a second, I'm not run this value yet. So now I can see the score based on what the predicted and the actuals are, right? So you can see that roughly you will get to see what is the mean absolute error or root mean square error and so on and so forth. These are values that are going to be available for us to go and use and interpret. Okay, so this is one level of scoring. Now I can table this as a linear regression score. Now typically we do run multiple techniques and then see which ones give us a good lift or good predictability, so to speak. So in this case, I'm going to run another example, let's say a random forest. Now you can see that there are other techniques available, maybe XGBoost and stuff like that, which you can run much later. But for example, yeah, one other thing is when you search for regression, you'll get logistic regression, but logistic regression is a classification technique. Just remember that. Don't use that for regression here. Okay, so I can see a random forest and so on and so forth, right? So I will that's what I'm running. So it's very simple, similar step. The underlying technique is going to be taken care by the widget. All I have to say is what is the target column, what am I going to look at, and then I don't know why this is super rich. It should be medium income or so, right? So I'm trying to predict the same medium income and apply the set of columns that I've chosen and so on and so forth, right? So you can keep that as simple as that. Now this model may run a little bit, and then you will see that you can, so random forest actually, if you can look at the description as well here. So you will see that it is using multiple models beneath it. So to really give me 1 second, where is our friend random forest here? Okay, so you can see the help here. So it is building on the back of a lot of decision trees behind the scene and running multiple decision trees to give you sort of an average of these, right? So that's what you will see, right? So that so you can see these help and descriptions quickly. Now I've run the learner, the model, and then now I'm running the predictor using the test data set to predict and so on. And then I'm going to this is probably not set up proper. Okay, so I don't know why this is maybe I was playing with it earlier. So this is my test, right? Or okay, all right. So I'm going to feed the output of the learner back to the predictor, which so the essentially the model is the model, whatever is the learned model is my input. That's the primary input to this, and then I have my test data set, which is supposed to be coming in. I'm not sure why this is got connected. I think that's a mistake on my part. Okay, so I'm just going to connect the test data set and the model from the learner part. This would be the simple input. Now once I have it, again you will see that similar to the linear model, you could save the changes, whatever is the prediction column name and so on and so forth, right? Now change the prediction column, so I could so in this case we have used, I don't know why it keeps switching to super rich for some reason. We had the medium income, I'm just going to use the same name, right? Medium house value, give me 1 second. Yeah, medium house value, I'm just going to use the same name. So let's just make sure, yeah, I'm going to choose the medium house value here, apply, save, and then when we predict, we're going to use this I think I'm just going to use this, run it once. Let me run it so that you get the column, the model target variable as an input to the predictor, right? So we should see the change, and the change should be this. I'm just going to use random forest RF as a label, and we're just going to run this, and see what happens, right? So you will essentially see a similar prediction, and run the column sorter as well, where you can see the column for the median housing value which we had here, right? So you will see that if so where is our, okay, so I'm just going to show it in the statistics so it's easier to see these values. So you will now see that there should be both random forest predicted value as well as the income value, both are there, and I can use this and compare. So now I have a scoring that I can apply to, I think something got changed. Yes, so this is what I want. Okay, now I execute it, I'll get some value. So now you can see that, so like here again you will see coefficients and where is our give me 1 second. Yeah, so essentially what I was going to say is we will get to see the coefficients as well as the final R square values and so on, and you can compare. Now you will see that random forest is probably slightly better than the linear regression in this case, or whatever input we gave. So it's about able to explain the variation little better. So 0.78, if you remember the linear regression, it was 0.669 or 0.67, right? So much better than the linear model, right? Now I can apply other techniques, and then I can go back and so once I know these predictors and so on and so forth, so ideally you will start to now iterate through this process, right? So as you can see, now if I don't need certain columns, I know that some of them are not going to make much of a difference. I can ignore them, or some of them are correlating much better with few other attributes and so on, we can ignore them. So you can play with the input. The point is you don't just run it blindly and then stay put. What you can see is once you created the model, you got the scores and you got the output. You could so now this is one step. I can also go and compare them, put these against a table, compare the values out of the random forest and simple regression as well, and do a visual to see what is the value, and then I can also have a predicted value attached for both these and for the test data set and so on, right? So there you have it in terms of being able to quickly look at model training, model preparation, and so on and so forth, right? Now, like I said, the actual model exercise is more not just a one-time exercise. You will go through iterations and so on. So that's where we will go through the next steps, where we look at parameter tuning, feature scaling, and there are a couple of approaches to improve the model, right? So your endeavor is to see, hey, I got a certain R square and certain predictability with the model. Can I use certain techniques based on the learning to improve the predictability as much as I can to an acceptable limit? And then, if you can get to 80%, 90%, whatnot, then you could stop at that time and say, hey, I'm satisfied with the model. Now let me go forward with that, right? So this is the process you saw. In the next video, we will try and look at a couple of techniques from a tuning standpoint, improving the model score and so on and so forth. But this is the crux of it. We've gone through analyzing the data set, understanding it, which is what took a bulk of your time. Then the data preparation, which is another important activity which will take time, like we saw, right, in this video, where we have quickly looked at missing value treatment, categorical treatments, as well as skewed data set, right, and then scaling and all that. And after all of that, you have a file which is prepared data that's good, and now I can start to feed that into the model. And in the model building, you're going to build a couple of models, not just one, and try and see which ones give you a better result and go and use it, right, after tuning and so on and so forth. Okay. So hopefully you're able to follow the process, the steps. I've not gone deep into certain other aspects in terms of to keep the learnability little better. So you can play with certain things in terms of analyzing more data set, in terms of removing certain columns before feeding the model, and so on and so forth, right? But we will do some of that in the next video. Hopefully you enjoyed this video. Subscribe to the video, give me a like, give me your comments, and we'll see you in the next video. Thank you very much. Bye bye.